this is Marshall Jordan. I have an interest in the mathematical problems associated with the theory of evolution. This presentation concerns the statistical barriers to the self-assembly of biomacromolecules. And I use a virtual monkey with a typewriter to be a computer simulation of the mathematical problems associated with evolution. We begin by considering the evolutionist view of the universe. The evolutionists envision a seven-step process, beginning with the Big Bang, cosmic evolution, solar system condensation, chemical evolution, macromolecular self-assembly, abiogenesis, and finally macroscopic Darwinian evolution, or so-called microbe-to-man evolution. Now, all seven of these scenarios have philosophic and mathematic problems associated with them. We're going to be looking just at the macromolecular self-assembly. Macromolecular self-assembly is envisioned to occur in a primordial soup containing organic molecules, including nucleic acid and amino acids, which spontaneously form polymers of nucleic acids, DNA and RNA, or proteins made of amino acids. Spontaneous generation of a macromolecule of specified complexity containing information is the final result of this process. When I was in college in the early 1970s, the mathematical problems with the theory of evolution had become a topic of discussion. But whenever an objection was raised on a mathematical basis, a standard answer was given, which seemed to satisfy me completely at the time. I don't think I gave it near as much thought as I should. The standard answer that was given was this. The standard answer given to any mathematical challenge to the theory of evolution was simply this. A monkey pounding randomly on a typewriter, if given long enough time, could eventually type the novel Gone with the Wind without error. I'm amazed now that I accepted this answer for over 10 years until someone pointed out that it just didn't hold together mathematically and was really not an adequate answer at all to the mathematical challenges to the theory of evolution. This argument has persisted on the college campuses of America. Here is the updated version. Notice that the monkey now has a laptop, and he's wearing glasses. He's a little bit older. But it's still the same argument. And this spring, when I challenged a student about the mathematical problems associated with the theory of evolution, she responded that a monkey with a laptop pounding the keys randomly could eventually type some large novel without error. The same argument. Now, this has seized the imagination of many, and you can find a lot of images like this on the internet. It's also gotten into the cartoon area. Here we have the savage chickens, and one says, theoretically, 1 million monkeys at 1 million typewriters will eventually write Hamlet. And you see this monkey down here, clack, 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 typing on a typewriter. From an evolutionary standpoint, hasn't that already happened? I suppose if Shakespeare evolved from an ape, it has happened. The program simulates a monkey with a typewriter, and I want to make it easy for him to get the result. So he's going to have a typewriter with only 26 keys, all caps. And he's going to randomly type the keys. Now, I'm not going to ask him to type the entire novel Gone with the Wind without error. No, it's too hard. We're going to ask him not to do the first chapter or the first paragraph or even the first sentence. He just has to get the 15-letter title, Gone with the Wind, all caps, no spaces. The basic program is this. The monkey must get the entire string, Gone with the Wind, on 15 consecutive keystrokes without error, or he must start all over again. The chance of getting G on the first keystroke is 1 over 26, using this simplified typewriter. The chance of getting a GO on 2 consecutive keystrokes is 1 over 26 squared, which is 1 over 676. And the chance of getting a GON on 3 successive strokes is 1 over 26 cubed, or 1 over 17,567. Now, the chance of getting the entire 15-letter string Gone with the Wind on 15 consecutive keystrokes with the monkey randomly punching the keys is 1 over 26 to the 15th power, which is 1 over 1.68 times 10 to the 21st, or 0.596 times 10 to the negative 21st. I wrote the number out with all the zeros so you can see how vanishingly small this number is. The chance of the monkey getting this 15-letter string is one chance in that many. This is incredibly small chance. You should be very impressed with that result. Wow, that is small. This is the program written in Hand Basic for my iPad. Line 20 gives the register which counts how many trials. Then a random number is generated multiplied by 26, and that produces a number between 0 and 26. Now, if the number is greater than 0, less than 1, it's an A. Greater than 1, less than or equal to 2, it's a B. Greater than 2, less than or equal to 3, it's a C, all the way down to greater than 25 and less than or equal to 26, it's a Z. Now, if a G is generated on the first keystroke, the monkey gets to go on and try a second keystroke to see if he can get an O. Otherwise, he has to go back and start all over again. That's what happens in line 96. Go back to 20, start all over again. Here's more of the program. If the monkey gets a G on the first keystroke, he gets to go on and try a second keystroke. And we see that in line 205, where another random number is generated, multiplied by 26. Now, if it's greater than 14 and less than or and equal to 15, then it's an O. And so then he gets to go on and try a third keystroke to see if he can get GON. Otherwise, he has to go on back and start all over again, and so on. Can he do it? Well, let's see. Here's the results of running the program. Initially, I had it print GO. Every time it got GO, it would print, but then it just ran GO down the screen, GO, 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 all the way down the screen. So I had it print only when it got GON. And when I hit run, it would go GON, 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 GON in a random fashion. And running the program, the probability of getting GON was on the average of 0.000064 per trial. And this compares favorably with the expected result of 1 over 26 cubed. Now, in a million trial run, I got 4 GONEs. I expected only 2. An all-night run gave 30 million trials, and I got 70 GONE for a rate of 2.31 times 10 to the negative 6, and I expected 2.19 times 10 to the negative 6, so it's very close to that. I got 5 GONEWs for a rate of 6.15 times 10 to the negative 7th, when I expected 0.84 times 10 to the negative 7th. I think if I had many more trials that number on GONEW would approach the expected rate. I got no GONEWIs. But 30 million trials doesn't come close to 3 billion trials, and I expected 1 GONEWI every 3.24 billion trials. So, of course, I didn't get any. Conclusion is this. The number of possible combinations of 15 letters is 1.68 times 10 to the 21st. When the number of trials exceeds half this number, or 0.84 times 10 to the 21st trials, the probability of getting the string Gone with the Wind becomes more likely than not. And I use this as a definition of success. At 100,000 trials per minute, this would take 8.4 times 10 to the 15th minutes, which is 16 billion years, longer than the alleged age of the universe. Running 100,000 trials per minute, this program is unlikely to randomly generate the 15-letter string Gone with the Wind in 14.7 billion years. So if you can't get the 15-letter title, you can't get the 2 million letters of the whole novel. Therefore, it's impossible for a monkey randomly hitting keys on a typewriter to type the novel Gone with the Wind in a universe of only 14.7 billion years duration. In the discipline of information science, the information coded in a sequence of letters, or coded in a sequence of binary numbers as in a computer program, or coded in a sequence of amino acids in a biomacromolecule, from a mathematical standpoint, these are all identical. Combinatorial space has to do with the number of possible combinations of a sequence of letters or numbers or amino acids, and the number of possible combinations goes up astronomically with the number of units in the sequence. Functional biomacromolecules, such as proteins, contain hundreds of amino acids, and so there's an enormous combinatorial space associated with randomly assembling a macromolecule from amino acids. Let's consider the macromolecule hexokinase. It's a very common molecule because it's involved with the first step in glycolysis, and this protein enzyme is present in most living cells, from bacteria to the cells in your body. So wouldn't this be a good macromolecule to self-assemble if the evolutionary scenario of macromolecular self-assembly were really true, something that could happen? Is it mathematically possible for this giant molecule to self-assemble? Hexokinase has 460 amino acids, and there are 20 proteogenic L-amino acids. So the number of possible proteins you can make from a string of 460 of the 20 proteogenic L-amino acids is 20 to the 460th power. If amino acids in a primeval soup could randomly join to make a protein 460 units long, is it possible a functional hexokinase molecule could be produced? The possibility of an unusual event occurring is determined by the probability of an event occurring and the number of trials available. For example, if you have a bag of 10,000 white marbles and you make one marble red and mix it all up in the bag, and then you draw randomly one marble from the bag, the chances of getting the red marble is 1 over 10,000. But if you draw 5,000 marbles from the bag, then you have a 50% chance of getting the red marble, and every marble you draw thereafter, you have a better than not chance of getting the red marble. So, there is a theoretical limit to the number of events that can occur, or the number of times amino acids can interact, simply bumping together with the possibility of forming a bond in a universe of finite age. There is a theoretical limit to the maximum number of interactions that can occur in our universe. A physical transition from one state to another cannot take place faster than light can traverse the smallest physically significant unit of distance, which is an indivisible quantum of space. That would be a Planck distance, the indivisible quantum of space of 10 to the negative 33 centimeters, and the Planck time is how long it takes a photon of light going at the speed of light to cross this distance, which is 10 to the negative 43rd seconds. So the maximum number of interactions per second that can occur in our universe is 10 to the 43rd. Now, the age of the universe is alleged by the evolutionists to be 14.7 billion years, which is 10 to the 17th seconds, and the number of atoms in the universe is said to be 10 to the 80th atoms. Therefore, the maximum interaction since the alleged Big Bang 14.7 billion years ago will be the number of atoms times the number of seconds times the number of interactions per second. 10 to the 80th times 10 to the 17th times 10 to the 43rd, or 10 to the 140th. It's impossible for a biomacromolecule to self-assemble by random bonding of units, because a 460-unit protein like hexokinase would not be likely to randomly assemble in less than half of 20 to the 460th trials. And a universe of 15 billion years duration allows only a maximum of 10 to the 140th trials. Since 20 to the 460th is far greater than 10 to the 140th, hexokinase can't randomly assemble. Now, this whole computation greatly underestimates the magnitude of the problem. Let's look at some considerations. First is L-amino acids only are found in living cells. A non-biologic production of amino acids in a primordial soup, as envisioned by the evolutionists, akin to the Miller experiments, would produce a racemic mixture of right and left-handed forms. So instead of 20 proteogenic amino acids, you would have closer to 40 right and left forms of each. But only the left-handed ones are used in living cells. And so a naturally occurring hexokinase, for example, it wouldn't have a probability of 20 to the 460th, but 40 to the 460th probability of randomly assembling. Next, peptide bonds only must form between the amino acids. It turns out that a solution of amino acids sitting at room temperature doesn't form peptide bonds. It just sits there as amino acids. And even if you could get a reaction going where the amino acids would join together, it's likely they would join by the side chains and not pure peptide bonds. Side chain bonding between the amino acids would produce gunk, nothing like a functional protein. Thirdly, proteins have to be shaped properly and folded properly as they are produced. In a living cell, when they come off the ribosome, they are conformed into their tertiary shape, which has to do with their function. And if they are denatured, they no longer function. And so in a primordial soup, what are the chances of even getting a proper conformation of any amino acid string that's produced? And then there's post-translational modification of proteins with carbohydrate moieties and others which affect their functioning. But here's the real black icing on the bitter cake of evolution, is that multiple copies are required. One molecule of hexokinase does not a living cell make. Living cells have thousands of copies of each enzyme. And so the simplest free-living single cellular organism would have hundreds of different proteins functioning together with thousands, maybe tens of thousands of copies of each. And all of these have to be present at the same time to have a functional living cell. So how could abiogenesis ever occur? This monkey with the typewriter has finally been laid off. He can't possibly type the entire novel Gone with the Wind without error. He looks kind of depressed to me, and his arm's sore from all the typing. The time has come for the professors who believe in evolution to stop telling their students that the monkey with the typewriter is an adequate answer to the mathematical challenges to the theory of evolution. From a mathematical, statistical standpoint, this is not an adequate answer at all. What's the true answer then? How did the life get here? Job 38, 4-7 says this. God challenges Job and asks him, "Were you there when I laid the foundation of the earth? Tell me if you have understanding." John 1, 1-3 says this. In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God, and all things were made through him, and without him nothing was made that has been made. Revelation 4:11 says this. You are worthy, O Lord, to receive glory and honor and power, for you created all things, and by your will they exist and were created. The natural scenarios of evolutionary theory are not adequate to explain the origin of life or the development of life forms on Earth. And superficial answers such as the monkey with the typewriter are not adequately addressing the mathematical challenges to the theory of evolution. The whole problem with evolution is that information in DNA is the basis of life on Earth, and information only comes from an intelligent source. So the Bible is the adequate explanation of how life got here, explaining that God created it. I hope this presentation has been helpful to you.